Science is incredible, but as with whatever you do, safety should be your #1 priority. Before you begin construction of your solar oven, please keep these safety tips in mind. Be careful as you're cutting with scissors or other sharp materials to prevent any paper cuts and injuries. When going outside, be sure to have proper protection from the sun. Depending on the intensity, you may want to wear a hat, sunglasses, and/or sunscreen. The sun's powerful effects can be both amazing and dangerous. If outside for a long period of time, remember to stay hydrated. You'll be using a hot oven, so be sure to wear oven mitts and use heat-proof utensils where possible. Ensure that you and your peers are spread out so that no one accidentally bumps into the hot oven, and never leave hot equipment unattended. Make sure that the food you are cooking and eating is not raw. There are harmful bacteria in raw meat, and be aware of any food allergies that you or your peers may have. Be cautious of the materials you're using and ensure that your supplies are non-toxic. Be especially hygienic with the parts of the oven that will be touching your food. Make sure to have an adult supervisor nearby, and always remember, you must be safe if you want to learn and have fun. Ask for help and give help to your peers. Great work! Thank you for taking the time to understand these safety tips. Enjoy your project and good luck!
What is solar energy? The sun is basically a big ball of hydrogen atoms. Hydrogen atoms in the sun collide under the tremendous force of gravity, creating helium and releasing energy as light. This process is called nuclear fusion, and the energy released is called solar energy. Solar energy, or light energy, travels in waves at the speed of light, about 186,000 miles per second. Still, it takes about 8 minutes for the light from the sun to reach Earth. Solar energy is composed of many different wavelengths, most of which you can't see. Different molecules absorb different wavelengths of light and emit heat. For example, greenhouse gases like carbon dioxide and methane absorb long wavelength infrared light, but not shorter wavelength visible light. Objects like rocks and trees absorb both infrared and visible light, while clear plastic and glass only absorb infrared. The solar oven you will build in this activity uses these principles to trap heat. Aluminum foil reflects solar energy from the sun into the heating area. The clear plastic film lets in visible light and traps infrared light. This causes the interior of the box to warm up. The Earth traps heat in a similar way. The atmosphere lets in mostly visible light and blocks infrared. The Earth's water and land absorb light and re-emit infrared energy and heat, which you can't see. Greenhouse gases in the atmosphere absorb infrared light and re-emit heat, trapping it on the Earth. That is why an excess of greenhouse gases like carbon dioxide can cause global warming. But if the Earth had no greenhouse gases, it would be too cold for life to survive. Solar energy can also be harnessed by converting it into electricity in a solar cell. You've probably seen solar cells on rooftops near you. We won't cover solar cells in this video, but they are another important way that solar energy can be harnessed. Solar energy is a renewable resource, meaning we won't run out of it for a very, very, very long time. As long as the sun is shining, and with careful design, we can use solar energy to heat our water and homes and to provide electricity. I hope that by creating a solar oven, you will see for yourself how we can harness the energy of the sun.
First, cut a hole in your box that opens the same way as the lid. Now coat this flap in foil. Now open your box and put in black construction paper in the bottom. Cover the hole that you made with plastic wrap. Pull it tight and secure the plastic wrap with tape. Do your best to insulate the sides of the box with newspaper. The box can now be propped open with a ruler and the food can be placed inside of the box on a plate.
Alright guys, so here we have our little oven, our little project. Here we have our food that we're gonna be cooking today. As we can see, it's a marshmallow. This right here is a little temperature probe to see if our food's heating up with the project. And here we have our thermometer. As you can see, the food is currently at 81 degrees Fahrenheit. So let's go ahead and stick the food in our oven and go ahead and perform our little experiment here. So there we go, position food right there in the middle of the oven, propped up the reflector and angle the sun at our food. And so we're gonna leave it here for check up every 5 minutes on the food and see how the temperature changes as it cooks. Alright guys, it's been a full 20 minutes and we can see right here that our marshmallow and s'mores, our s'more has reached 120 degrees. So let's pull it out and see what it looks like. So here we go. Go ahead and pull this out. As we can see, our chocolate is fully melted, both of them. And our marshmallow is nice and squishy. Go ahead and take the probe out. Right there. You can go ahead and now mix our two halves. And there we go, guys. There's our s'mores. I can say that this project was a success, guys.
Now that you have watched the demos and completed the experiment, let us go over everything we have learned. Primarily, we learned the importance of safety and how to promote safety while engaging in this activity. During our experiments, we saw solar energy at work. Remember, solar energy is the result of nuclear fusions that take place in the sun. How were we able to heat up the food in our homemade solar ovens? Well, that was due to the plastic wrap acting similarly to greenhouse gases in our atmosphere. The infrared light got trapped in our oven, causing it to heat up. With this information, we now know the power of solar energy.